templates, you need to understand. You need to understand the concepts. You need to understand what is required as a practitioner, what is expected of you. I mean, being professional, that professionalism is very key. And that is why we're going through all this. Not just to just teach you the tools part of it. I mean, the culture and the discipline part. And I believe you guys have been enjoying this series of meetups we'll be having. We have two now. The first one was on Agile. Was on project management in the Agile way. And the second one we did on the Agile methodology. And so this afternoon, I'm taking you guys on a very important topic. Is a concept that which the whole IT world is standing on. If you take out that concept, then there's no IT. There's nothing like cloud.
Hello,
the cloud is.
Hello.
Yeah, can you hear me?
Sorry. I'm seeing a white screen on my side there.
Hey, don't worry,
Am I the only one?
Don't worry, I'll share my.
Okay. Sorry, I think it's my phone that is misbehaving. All right.
Let me share my screen now. Can you see my screen?
Yes, I can see your screen now. Yes, right. I can see your screen.
Okay, so we're talking about Windows Server administration and along with the virtualization technology. And I said that the virtualization technology is the foundation of cloud computing. That is the foundation of the cloud technology. Everything is built around virtualization because it's something you cannot see. There's an abstraction layer that you're working with. And so the way it's structured, I'm going to just take us through the theory. Like I said, about IP addressing, how do you manage a server? What are the things you need to know about a server? What is a server really? Why do we need a Windows server? And mind you, we have different kinds of servers. When it comes to the server ways, we have the Windows, we have Linux. So, but this afternoon we're looking at the Windows server administration. Now you can administer it. What are the basic things you need to know for you to be able to administer a Windows server very well and in a professional way? So we're going to go through the history of servers, see the types of servers we have, then talk about the virtualization technology, talk about hypervisor. And when we finish with that, we now go through hands-on class. We'll have an hands-on session where we're going to set up a virtual bus. I want to believe all of our virtual bus installed. Am I correct? Do you all have it installed? If you have installed your virtual bus, can you just signify by raising your hands? Just one person. Okay, almost everybody. Okay, that is fine. So for those of you that don't have it yet, so I'm going to demo it. We're going to set up a Windows server on the virtual bus and do some setup on it, and from there we'll stop. Once we're done with the answer session, we'll stop and we do another session on Wednesday night. We'll go deeper into what we started today, go into a more deeper session and more concepts on Wednesday night. So I'll start. I believe many of us, have you seen this before? Have we seen this before? Can you see my screen?
Yes,
yes, we can.
Yes.
Okay. So what is this? Who can just guess what it is like? What is this called?
a server room.
Somebody says server room. I love that. Server room. Somebody else.
Data center. It's data center.
So is it a server room or a data center? Which one?
It is a data center. Because you have series of URACs and clusters.
You can see racks.
Yeah, you can see different sizes of racks, URACs.
Yeah, so I remember when I started my IT career, I started with end user support, managing end users. And so, because I worked in the bank, and in every branch, we have what is called a server room, you get. So the server room is not the same thing as a data center. The picture we have here is a data center. You can see how robust the infrastructures are. You have series of servers inside this data center. Is the center we have, it's called data because of is housing data. If anything goes wrong here, then you have terabytes, if not even petabytes of data affected. And not just, you have millions of users will be impacted. Millions of services will be impacted if anything goes wrong in this server, in this data center. So server room is just what you have for a little building, and it will mostly have network devices, your routers, your switches, and maybe you have a power unit, a UPS, just to ensure that we have continuous supply of power in case of any power interruption. But for data center is more robust, it's bigger than what you have. So for a data center is, imagine you have whatever infrastructure or devices you have inside of a server room times, let's say even times 100 of such is what you are having here. So this is one data center you have. Imagine how Google data center will look like. And so this is what you don't see physically. Last 2 sessions we've had, I love the concept H brought into it. He was talking about the kitchen. They're trying to put things together to serve. And so what you have experienced so far is what I would call the front end. You are just like, imagine being in a party and you've been called to come and serve people. So you've been called as an event manager, let me call it such. Managing, ensuring that people get to eat what they want to eat, the whole place is well organized, and everything is fine. But before you get to that stage, some things have happened back end. So as a DevOps engineer, you put on too many caps. And one of the caps you are putting on is, at the back end, you are managing things, you are managing infrastructures to ensure that everything goes smoothly. We talked about Agile. We want to ensure that our product are turned out as quickly as possible. We make changes as quickly as possible. And the whole essence of making those changes is to ensure that we have a fantastic customer experience. The customers are always happy. The customers are able to meet up with what they really want. They have expectations, and it's always changing. So you want to ensure that as you are deploying to production, you want to quickly deploy them as quickly as possible. And so the project manager is just saying, hey, what is happening here? When are you going to go live? They are saying, don't worry, by Wednesday night, we'll be fine. But there are things we are doing back end, and that is what we're going to look at with our server management in class today. So this is just one rack. If you look very well, you can see it's like an Avaya rack with an Avaya devices, maybe for a call center or maybe for call making. You know what Avaya are into, mostly for IP telephoning. And so you see, these are just a section of what you can find inside the data center. It's all about servers. It's all about servers. So I just brought that just to give us a prep into what the data center is like, and to know much about the server. So let's go on. Windows Server Administration. So I'm going to take us through the operating system, because when you talk about a server can't run without an operating system. There's a system by which it operates. It's that system that helps you to be able to do everything that is expected of that server to do. You talk about an IP address, how you assign IP address to it, how is able to understand that, okay, somebody needs to connect to this server, how is able to manage the services that is given to the client operating system. So it requires an operating system too. So we'll talk about the operating system. You talk about why do you need a server? Why do we really need servers in our world? Why not just stay with our client operating system? Different between the server and the computer. I'm talking about the client OS. So we'll go into virtualization technology, look at the types and examples of virtualization, talk about hypervisors and the examples. Then we'll have our hands-on class or session. We'll talk about the IP addressing, user management, different server rules. So we come to operating system. And when you talk about operating system, it's just, you're talking about the software. And that software serves as an interface between your hardware and you, the user. So I have a laptop and I'm a user of that laptop. I want to do some things, I want to write some programs, I want to open some applications. And for it to be able to do that, the hardware needs to talk. They have some components that have been put together. You have your hard drive, you have your what's it called, your network adapter, you have your keyboard, you have your RAM, memory, and the likes. All those devices on their own, they can't do anything. They can't really, they don't have that intelligence, let me put it that way. But the operating system is able to, if you can see my diagram, you are the end user. So your operating system allows you to be able to talk. The hardware you have don't really understand your language. They're all machine languages. So the operating system helps you to manage that communication with your hardware. So all you need to do is to just come to your laptop, fire it up, and you go to start menu. You say start menu. Yeah, I want Microsoft PowerPoint. I want Microsoft Word and the likes. So the way helps you to communicate with the computer without knowing how to speak the computer language. You don't know the computer language. You don't know what is happening at the behind the scene. You just know when you press the start button, you see something will come up. You know when you want to go to Zoom, you just do start my camera or start my meeting. Is responding. All those things are handled by the operating system. And like I mentioned earlier on, we have not just the Windows operating system, we have the Apple OS, we have the Linux operating system. Yeah, so this afternoon, we're just talking about the Windows operating system. So talk about the history of the operating system. First one was developed in the late 1950s, and that was just done to manage tape storage. And there's been a lot of improvements, there's been a lot of development of the operating system. And there was a point in time whereby it was built by, the first OS built was by Microsoft, and that was DOS, Disk Operating System. And it was more of like, it wasn't user GUI like we see today. It's more of just command. You just write commands to operate it. And so because of there's need, you know, as users, we want to have a feel, I don't want to come and I'm just seeing black screen all around, I'm just typing something. So you want something that will change your experience. And to change the experience of the operating system, Microsoft decided to create the GUI. And they manage the GUI together with the MS-DOS. And today we have different kinds of operating system. And let's have a look at the market share for the operating systems. We have the Windows operating systems, we have the Android, those are the mobile OS. You have the iOS, you have the Mac OS, and the others. And you can see that Windows is not doing very badly. Windows has gone to an extent, you can see the percentage share of the share Windows is having in the markets. Next to Windows is Android. There's hardly any home today where you go to that you will not find the Android OS. You have a mobile device running on Android OS. There's hardly, if you meet with 10 people, at least 5, 6 of them will have an Android phone they are using. iOS is not still next, but the share is not as large as what you expect or what you get with the Android and the Windows operating system. So this is just the history of the OS and what is really happening today in terms of their market share. And if you really go, most companies just now with the word of DevOps that people are beginning to align with Linux, most people have the infrastructure built on the Windows server. They have the infrastructure built on the Windows operating system. That is the server operating system. And so we talked about the different type of operating system. There's one that is called the Bash operating system. And this one is just more about, you have different processes running on the particular system, and you just want to batch them together so they run as a group, or you have them like stuck together, they're running as a group, instead of you having them split together. So you just have one job running them together. And normally for the user of the Bash operating system, they don't really, they never directly interact with the computer. All they just need to do is prepare the job, and you can do an offline device and just punch a card and submit it to the computer operator, and they just manage the job for you. There's one that is called the time sharing operating system. This was the early stage of the operating system, whereby you have a simple computer. Yeah, those days, computer scientists, you have a simple computer and people will just come to book time. You might have, okay, you use it. You have multiple users just using different time. They allocate different time for them to come and use the device. So you have a CPU processor time. You might be given 2 hours, somebody else is given 3 hours, somebody else is given 4 hours. just sharing it along. So it's like you share around timing, but that's not the experience today. We have your real-time OS. I'm just taking those history. We're not going to dwell much on this one. Talk about the network operating system and the mobile OS. And I was telling us about the Android and the iOS. Those days, BlackBerry before it went hot. And you talk about wearable devices now. You now have the WatchOS. Those of us that have smartwatch, Apple Watch. That's that kind of operating system. Without that operating system, your hardware is not intelligent enough to function. Those features you see on your Android, those features you see on your iOS or mobile phone devices and your smartwatches, you are able to get those things. You're able to experience it because of the operating system there. And so when you try to dissect that operating system, for your operating system to be able to talk to the hardware, there is something that is called the kernel and the shell. Operating system does not just talk to your hardware. For it to be able to talk to your hardware, there's a component that is called the kernel, and that is the central component of every operating system. And it helps to manage the communication between the software and the hardware. You have softwares, like I told us, the operating system is a software. So it needs to communicate with the hardware. It needs to be sure that, okay, I have 8 gig of RAM. If you go to your system now, you want to see your system devices or the info, your system info, and you check, oh, I have 500 gig, oh, I have 16 gig of memory, I have, I'm running an i5 processor or an i7 processor. It's the kernel that manages that communication. So it looks at the hardware and check what is the spec of this particular hardware, and is able to give it to your operating system so that you can see it as a user. You don't understand that language. Your operating system is the one that understands the language, knows what to talk, it knows what to tell the hardware. And in doing that, it can get whatever information that it wants to get. So for the operating system to be able to communicate with the hardware, kernel is required. And that's the central component, it's a very key component. Without it, there's no how the OS can talk to the hardware. And it is the innermost part of the operating system. What you see there, the outer part of it is the shell. On my diagram, you can see. As a user, you bring up your terminal. Those are, if you are a little bit familiar with the Linux operating system, you understand this better. When you enter into your terminal, you need to come up with a shell. Are you looking at the bar shell or K shell? You understand that. And so that shell is giving queries, is giving commands to the operating system. And the operating system is not just for it to be able to respond and give you back response that you as a user will see on the terminal. It needs the kernel. So the kernel goes to the hardware and says, I'm getting a query from this user. So let me know what is your memory. Let me know what is your hard disk size. Are you using 500 gig? Are you using SSD? Are you using HDD? And the like. So it takes it and sends it out through the shell. The kernel gets it to the operating system. Operating system takes it to the shell. And the shell passes it out as an output to the terminal. And that's what you see as a user. And you can understand, oh, okay, I know what is happening. You can check and see, oh, processes are running on the system, which one is taking most of the resources. You can see and say, okay, who are the users that have created, all the users creating a user on the terminal and the likes. For Windows, talk of your PowerShell. All those commands you put in on your PowerShell to run queries, it goes into the operating system and the operating system feeds it to the kernel. The kernel goes to the hardware to get those information out for you. And so now let's come to what is a server. We've talked about the operating system. Like I told us, without the operating system, the server is not a server. And so when you talk about a server, I mean, really, the server also cannot operate without a client. And so that's why you hear most people tell you there is this server-client relationship. The reason why we have servers, the reason why we decided to, why the OEMs, the likes of Microsoft and the likes, the Red Hat company, decided to come up with server is because of clients have requests. They have requests, they have required for a service, or they require a service to be given to them. For instance, you are on this meeting today and you want to, for instance, let me give the instance of, I want to learn the VirtualBox. So you go to the internet and you click VirtualBox download or VirtualBox setup download. And you are the client on your own laptop, while on the web, on the browser. That request is taken and is going to a server. So imagine if there's no server, there's no way your request to be consumed, because as a client, you're always requesting, you are a consumer of services. You want to consume service. And so you need somebody that will give you that service. If that service is not provided, you can't consume it. And so that is what your server handles for you. So it's just a software component, or you can say a dedicated hardware. And all he's doing is he's able to accept multiple requests from multiple clients. You can see, imagine the number of people that are going to the internet. You go to the Google site. Most of us, you need anything you want to search, you're going to Google just to search for it. You want to get a server, a setup, an application setup, wherever you want to get more information and making some research about some, maybe for instance, some of us would have gone to the internet and check, they are taking us on Windows Server. What is really a Windows Server? All those information as a client goes to a server. There's a server at the back end that is taking your requests, takes those requests, does some check, navigation check, and see this person authentic. Is this person meant to even come to me? Where this request coming from and the likes? It takes it, interprets the request, and sends a response. So the request is sent to the server, and the server sends you a response and say, okay, I understand. You want to download VirtualBox. Okay, this is the site you need to go to, or this is, gives you a response of what you need to click on to download it. You download it and you are fine. And for you to do that management, you can either go through your internet or you can go through the LAN. For those of us that have that works in an organization, you know, there's a way they've done the segregation of your system, of your network. There are some things that you do that goes through the internet, and that's why you talk about the proxy server. No organization that is security conscious today will allow you to connect directly to the internet. Their servers will not go directly to the internet. There's something called the proxy server that will take that request. And so, okay, you want to go to the internet, take that request and check based on some permission you would have given and said, okay, this particular user or this particular server can be accessed. If the proxy server sees that there's a permission that says you can't go, and that's why most of us, when you go, if you check, if you are very observant on your office laptop, there are some sites you can't open. There are some office organization that will tell you, we don't allow you to go to. Can you all hear me? Can you still hear me?
Sure, we can hear you.
Yeah.
All right. Okay, thanks. So this is just the basic definition of what your server does. So I've told you, it takes requests, multiple requests. It's able to handle a lot of requests. And that's the whole essence why you need a server. The kind of request that your server can handle in terms of the processing power of a server is much more higher than a client. So imagine YouTube, you can imagine the kind of server they'll be running. That if you want to give that kind of request to a client, no client can handle such kind of a request. When you have, let's say over 5 million people at a time, want to stream, they want to check what is happening on YouTube, watching video, doing live streaming on YouTube. A client can handle such kind of a request. So those kind of request goes to a server. Server helps you to manage that kind of request, and it will always give you a response. And in our hands-on class, we're going to see how those requests are being managed, what are the way you expect the server to respond when it gets a request. It's not every request that the server gets that the server responds to. It is not every request. We are going to go into that and you understand it better. So I decided to make this much interactive, so I won't be the only one talking. These are different kinds of servers that we have. If you look at the picture very well, I've made it in such a way that you'll be able to tell, if you just observe it very well, you can tell what kind of server we are talking of here, just by observation. So who wants to go out first? So we have 6 categories of servers. There are a lot of servers, depending on what function or what kind of role you want the server to play for you. So I decided to bring out C. These are common ones that you will always see. Common ones that will be used in organizations. These are common ones that you'll be exposed to on the field as a DevOps engineer. So who can just help us out? I want to give us, do I even make it? Okay, let me do it. Since we have groups now. Somebody from the Agile team, can you tell us? Just pick one server. Pick one server type and tell me what server you think it is.
Yeah, this is Bamdele. Can you hear me?
Yeah, Bamdele, I can hear you.
Yeah, thank you. Yeah,
bottom right. Web server.
We have
the bottom
FTP
right is the
server.
web server. You're correct. Yes,
The one.
correct.
Oh,
You can see a globe. You can see a globe icon there. So that tells you that you're talking about the web. You're talking about the browser. So it's a web server. Correct. Yes. Who else again? Thanks, Bamdele, for that.
The middle after the good afternoon. Good afternoon. My name is Liman.
Okay, let's do it like this. This is 1, 2, 3, 4, 5, 6. So when I start from my leftmost top, that is 1, 2, 3. So we have 6. So somebody has given us 6. Somebody told us 6 is a web server.
Number 5 is mail server.
Number 5 is what server?
Mail server.
Did you say mail server?
Yes.
Yes, that's correct. Mail server. You can see that heart and an envelope. That is an icon for mail, for email. The mail server.
Number 3 is the domain name server.
Yes, domain name server. So that is a DNS server. Number 3 is a DNS server. We're still going to talk about DNS servers and why do you need the DNS server.
Number 2.
Yes,
Number 4 is the local.
Number 4 is a what?
Number 2 is a database server.
Number 2 is database. Yeah, I agree with you. Number 2 is database.
Number 3
is
file share server.
Yeah, that's the file share server. We call FTP server, yeah?
Number
1
server.
Application server.
Very good. Who said application server?
Liman.
Human, yes. Many of us are very used with this. We're used to these servers. So we have the file server, we have the database server, the DNS server, application server, file server, your mail server, and your web server. And so you talk about your mail server. Many of us all have email addresses. And the only way that we are able to send emails, you receive emails, somebody send an email to you, can receive it, they attach it, and the likes. That behavior is handled by a mail server. Without a mail server, you will never be able to send an email out. We all have a Gmail. Many of us, when we applied to take part in this mentoring class, we sent email out to you guys, congratulating you on your acceptance into the mentoring session. So all those things is handled by someone, by a mail server. So the mail server is able to take that request and say, oh, there is a shown with a particular email address and is sending it to this particular box. He understands it, and all those things they write on IP. That's why I was to talk about IP address. Now you assign IP to a server. They're all about IP, and that's the only way that the email is able to go through. You just imagine, how am I able to send email? For instance, we gave you our info at daas.ng, and daas.ng. Are you able to manage that? Please, sorry. So how is this mail server able to know that this mail should go to Dapo, this mail should go to Sean, this mail should go to Bamidele and the likes? Because there's an IP behind the scene that is talking to one another. And so with that IP, you can never mix it because it's unique, and you can't have 2 servers or 2 clients having the same kind of IP. If it does in a system, in an environment, there will be something called IP conflict, and it will never work. And so you have your file servers, you all share files, you attach PDF. Those of us that are in corporate environment, they create a storage for you, a file server. You have a directory you go to, and they tell you, for this directory, when you scan a document, maybe for instance, you have policies, your SOPs, and the likes. They have a file server, a file path that have been created for you, and those documents are placed there so that you can go there and check and access at whatever particular time you want. You have your application server. We all know different applications that many of us will have. Your Zoom, for you to be able to work, there's a server that is taking the request from your Zoom. All on this meeting today, there's a server that is managing this request for us, and that's how we can be on this meeting. Without it, it won't work. Those of us that have our bank apps, there's an application server that is taking care of it. And when you log into your application, your bank application, whatever bank you use, or those that have the fintech have different kind of applications, there is a database behind. And that database is what helps to store your data. That's what it's handling for you. And that's the reason why when you log into your bank account, you can see the balance you have. You do a transfer. And so I'm transferring 5,000 naira to whoever. It's able to store that information and says, okay, the balance has dropped by 5,000 naira. And if there is no database, you can't have those information. The application is not able to handle that on its own. So it needs a database that is talking to and is able to query requests at every particular time. When you check for your balance, I want to check my account balance. The application server is going to a database to pick that information and it's giving it to you. Those are things, that's to tell you the wonders of the server. And so there are still many more servers aside of all these ones, depending on what you really want. So you can always create your roles, and you have a feature on your Windows server that helps you to create whatever role you want to create. We see something that is called roles on servers. So you want to create, the role I want to create is a DNS server role. It will help me create it. If it is a database, it will help me create it. If it is a mail server, it will help me create it. There's something also called, let's go to the next slide. Yes, there's something called the DHCP server, the DNS server, your AD, Azure Directory, your Active Directory. I was saying Azure AD. Your Active Directory. You have your print server, you have your SQL server, database, you have your IIS server, Internet Information Service. And that is the way through which your web server is able to communicate when you deploy and go to your web page. So all these are types of servers that you have. And really, I brought this architecture hard because if you're going to set up a DNS server, a domain controller server, you need a DHCP server, you need a DNS server, you need your AD, your Active Directory. And I was talking about when you log into your application, for instance, those of us that I always like to refer to our corporate environment. You are given a laptop, or maybe you have a desktop that is provided for you, and they give you a username. You are given a credentials, username and password. And for the client to be able to admit you in, it's not actually the client that is admitting you in. There's a server behind that takes that request. I told us when you talk about servers, there must be a client. There must be a request that is receiving. If there's no request coming from a client, then the server is not a server. So the server is expecting the request. So you put in your username, daas.ng, and it tells you what is your password. If you put in your password, the AD queries it because you would have been created on the AD. And so it's checking and saying, do you have any user that is called daas.ng or have a user called daas.ng? Then what password was provided for it? It looks and verifies. This password is okay, it's fine. So that's what your AD does for you. AD is just to handle your identity management. And it's checking, is this person really who he says he is? If he's telling me that he's daas.ng, am I sure it's daas.ng that is logging in? Or I've been given a password that said Oluwaseun at daas.ng. So it's checking, is this Oluwaseun really? Oluwaseun, maybe there are other Oluwaseun. So how am I even sure it's Oluwaseun that is coming in? How am I sure it's not somebody else that is trying to use his name? So it tries to give you a challenge and tell you, what's your password? And you submit that password, or you enter in your password, and the server will check and see this, the password you have given me, is it the same server? Is it the same password I have on my system? And if you check and confirm, oh, that's what I've stored, okay, it allows you to come in. If not, it tells you wrong password. So anytime you want to check your email and you see wrong password, there's something behind that is doing a check, but you don't know, it's very fast. It has done that check within the field of seconds, and it's telling you, I've checked and I can't validate that your password is correct. It tells you a wrong password, you can't come in because what I've been designed or what I've been created on this system is not what you have provided for me. So give me the right password and I'll allow you in. These are all the kinds of servers we have. And do you have any question before I go on to the virtualization points? Do you have any question you want to ask?
Yeah, sure. I think there's a question on the chats group. on the chat room, someone is asking that what's the difference between web server and application server? So that's the first question. Then second one is, okay, the user is also asking that also, can a single server perform all these functions?
Yes. So you can have a single, like I told you, they're all rows. So I can create, when we go to the hands-on session, you see it better, you understand. I can create a row for a web server. I can create a row for a DNS server. Most times you have, most people want to use DNS server. They want to use your DHCP server and your AD server put together on one server. It can work that way. But for best practice, it's always best that you have them on different servers. For instance, if I have a single server that is handling DNS, handling email, handling application, handling file, if anything happens to that server, then it means email is going to be down, application will be down, DNS will be down. The instances in your organization whereby you will see people say, I'm trying to go to this particular application, it's not loading, I'm getting error. Or there are times whereby you see people will tell you, our email is going, like there was an instance that happened whereby people will tell you, I'm able to access other applications, but email is not going through. Email is having issues because of the application server is fine, but the email server, yeah, that is correct, UK maker. So the email server might be having an issue. There might be a problematic issue with your email server. I'll give an instance. I was told of something happened on Friday. Was it on Friday or on Thursday? I had that experience, and there was a vulnerability that Microsoft detected, and because of that, it impacted mail service. Okay, I think I remember that. But just remember there was a time we had issue with email. If you still remember then. And so,
yeah,
what happened? Not until we went online and found out that Microsoft did a change globally that impacted email. And so everybody was also wondering, what is happening? We cannot send email. What is the issue? What issue? We check the server running very fine. There's no issue. We try to check the event log. We can't see anything, any error log that pointed to that issue. Until we went online and checked, and Microsoft released a document saying, okay, there is an issue with this particular service. We decided to do an upgrade and impacted a lot of people, and mostly it was people in the Middle East Africa that were affected. And so a particular region were affected. So it's always not good that you have all your servers, all your roles put on one server. If anything happens, then you have multiple applications being affected. And that is not the agile practice. You want to be able to put them on different components, or that way you have the containers coming in containerization, so that you can easily dictate if there's an issue. For instance, if I have 4 rows on one server, all the rows might not be having issue, might be a particular row that is having issue. So you spend more troubleshooting time to really find out which one of these rows is having the issue. So you go with, for instance, you go to your print server, you check, everything is found on print server. Okay, you go to IS server, everything is found on IS server, the IS row. So it will take you long troubleshooting time. But when you have them splitted, you've created a dedicated server for IIS, you created a dedicated server for print, is a dedicated server for the DNS. You can quickly isolate the issue and get it resolved. You know, we don't want to encourage time. For agile methodology, there's nothing like downtime. You want to minimize your downtime as much as possible. If any issue happens, you want to come back, restore services as quickly as possible, in a way that even the customers won't even know there was an issue. I believe I've answered that question. The person that asked, is it clear?
Yes. Okay. So in addition to that, right, Sean, so in addition to what Sean had explained, and let me just kind of like add, to the question that was asked, where the person was talking about the difference between web server and application server. So basically, right, there's no much difference between, a web server and an application server, right? So, but the only difference between the two, okay, basically they both accept HTTP requests, and we all know what HTTP is. HTTP are just web requests, right? Once you visit a web page, Facebook, Instagram, what have you, once you just type that within the URL, what it means, just like Sean just explained, is that you are the client, you are calling a particular page somewhere on the server, right? So at the point of calling, what is happening is that you are invoking a particular protocol, and that protocol is called HTTP, right? So now the server that handles that request, right, can either be called a web server or an application server. Do you understand? But when it now comes to delivering content itself, right? For static contents are contents that you can only see, like you can see the content on the web browser itself, right? Now that content is being handled by a web server, right? Why an application server are servers that you yourself, right, you'll not be able to see the functions that they are performing at that particular point. They are more or less called a backend server, right? And what they do is that they deliver dynamic content. Now, what are dynamic contents? Dynamic contents are things like your APIs, things like your JSON application that, that are doing the heavy lifting. And that is why an application server, right, handles longer running processes. They are much more resource intensive. While a web server, which passes the front end that you can see, they are not that very resource intensive, because just like someone said, Chukwuemeka, right? The web server, you can have like 20 web servers that does high availability, that spread across broad to be able to handle the request. So the web server, in summary, they do things that do not really require much resource, that are not very resource intensive. Do you understand? They serve only web-based applications, and they deliver static content. That's for web server. Why an application server, right? They are much more for things that are very resource intensive. They can serve both web applications and backend or enterprise-based applications, just like I've said, APIs and what have you. And then lastly, they provide dynamic contents that you can't see. Then one last thing is that a web server, right, cannot in a way communicate in itself, without the application server. And it is bad practice for you to have both your web server and your heavy lifting application running on one server. Just like Sean said, right? If anything should happen to that server, then there will be downtime. So I guess that should give like a proper overview of what a web server and an application server does. Right. So okay.
Thank you very much, Jack.
Yeah, sure, you can go ahead.
Thanks so much. So just to put it in perspective for us, he has given us a very detailed technical explanation to it, and that is just the difference. So imagine you have Gmail. Most of us will have Gmail. There's the hub. At times, they'll tell you, download. Do you want to download? You go to for instance, you go to the web. So when you talk of web servers, they are talking about the web application. You are going to the web. The browser is required. So you go into your web, your Google browser, your Safari browser, your Edge browser, and you enter in gmail.com, and it takes you want to sign in? Yes, I want to sign in. You sign in. There are times they tell you, do you want to download the app? So if you don't want to go to the web, I don't want to go to a browser, then they'll give you an app that you can consume that service on. Or you say, no, I want my web server. And there are times for those of us that have our bank applications, there are times you don't want to go through the app on the phone. You want to come to your laptop and so, okay, let me go to the browser. So you go into the browser and log in. See, that's where you have the internet banking page. So when you have page, that's the web browser, the web app. So that's just the difference. And so let's continue. I'm happy that we're all getting it. Yeah.
Sorry, Sean, there is another question. So I don't want us to, answer all the questions as they come in. So Chukwuemeka is asking that when using AD I believe AD here is Active Directory, that when using AD for authentication, is it the server that does the verification of user login information or a validation code process that checks if user login info matches what is stored in a database, which is DB server in this case? Please help me clarify. I'm a bit confused in this scenario with regards to AD. Okay, so I think Sean will still talk about server roles, right, Sean?
Yeah,
or that would be okay, server rules. So when we get to server rules, I'm sure that Sean is going to clarify more on that. So we can go ahead, Abby. Or do you want us to just talk about it now, Sean?
Well, let's talk about it. So your AD on education is a role, you get, and when you create that role, so there's a person that handles the check. Part of what you do is you have as the AD architecture. You can create, there are some other components like OUs, like users and groups. You get, so for every user, there's a password that will be created. And so your AD is meant to handle authentication. When the request comes in, for instance, I have, and you know, for you to have an AD, that's why you talk about it. Okay, where's mine? I talk about the domain controllers, the DCs. You get, so for AD to work, there must be a domain controller that is saying, okay, you are talking to a domain. So what domain are you logging into? So for your AD server, you have to join it into a domain, and you coming in as a user on that domain, you can create users, you can create group. And there are times whereby, for instance, you can create groups and say maybe application server group, database admin group, and you put some rules there. You create them on an OU and say, for this particular group, these are what they can access, these are what they cannot access. And you create users and put them on those containers. So if a user is logging in, when you present your credentials, the AD is able to check and see and say, okay, what is happening here? This person has given me, there's a password that I'll go on that section, I'll create and you see it there. So when you create that password, when you create the user and you create the password, it's going to do that check. The AD will do the check for you. The server is doing that check for you and saying, because it has studied well for it, there's a place where it has studied for you. And it's checking and saying, from what has been stored and what you are presenting to me, are they the same? If it does that verification and it's not the same, it will deny you access. But if they are the same, then you get an access into it. I have a demo, I'll do it for you and we'll see it there. So let's continue. When we get to the demo, I'll bring that on for us. So yes, we talk about the deal of the day, and that is virtualization. Many of us have been hearing virtualization, virtual server, VMs, and the likes, and you wonder, what are they really saying when they talk about virtualization? And really, what you're just doing with virtualization is, I have a physical server, and that particular server I have, or that particular, it might be a server, it might be your own laptop, it's an hardware. I want to share the resources into different, I will divide it across multiple computers that are virtual. Virtual means it is not physical, it's abstract. And when you talk about anything that is abstract, it's something you cannot hold physically with your hand. Once I cannot hold anything physically with my hand, then it's virtual, it's imaginary, but it exists. It exists. For instance, let me say, I'm feeling happy today, I'm joyful. You can't hold joy. You can't say, let me go and hold the joy in his heart. But you know I'm joyful. You can see the expression and you know it exists. So for virtualization, it's just a software that used to create an abstraction layer. Something that is abstract is a layer that is abstract that you can't see. It's not physical over a computer hardware. And it allows you to distribute the hardware, the components. And when you talk about the component, you talk about the processor, the memory, the storage. You can divide it across multiple VMs, multiple virtual machines. When you're talking about virtual machines, you are talking about virtual computers, virtual PCs. So when you hear VMs, what they're telling you is a PC. It can be a server VM, it can be a client VM, your client OS. So everything in the world of infrastructure, you're always talking about client or server, client or server, client or server. So the VM is just more of, you're talking about a virtual computer. So I have a laptop. I want to install more operating system on one particular laptop. I have just one particular laptop, but I want to install like 5 OSs. I want to have Linux. I want to have on Linux. I want to have different distro. I have the Ubuntu distro. I have the Fedora distro. I have the CentOS distro. And for the Windows, I want to also have like 3 other Windows servers. I want to have 2019, 2022. I want to have 2016. You can put all those together on one particular hardware, one particular laptop. And that is you're able to do that because of the technology that is called virtualization. And I gave a summary of it. There is a process that allows for more efficient utilization of a physical computer hardware, and is the foundation of cloud computing. That is when you have about cloud. I'm using Azure, I'm using AWS, I'm using Google GCP. All they are doing about it is just virtualization. For that to be possible is because they are applying the virtualization technology. Without it, you can't do that. You can't have a VM spin out in seconds for you. So you are utilizing the computer hardware. And so my laptop, imagine what I would have spent if I want to go and get 6 servers, physical servers, and install Linux, install Windows. Imagine I was spending so much money. And so because I don't want to spend that much, I have a laptop. So I can set up servers for tests on my laptop without going anywhere, without even entering to the server, the data center. I can just do everything right from my own laptop and I'll be fine. And whatever resources I have, whatever memory, whatever storage processor I'm using is what will be assigned to those particular VMs. So if I'm using an i5, for instance, what the VMs will be carrying, they'll be carrying i5. So the storage the VM is using, this VM is taking a storage from my computer as its own storage. So because of, there is something I will not talk about, which is hypervisor. The hypervisor helps you, when you create those VMs, the VMs in their mind, they assume they are running on a physical hardware. So they don't even know it's even virtual. To them is, oh, there's a hardware, there's an hard disk I'm running on from. I have this memory, I have this processor I'm using to run. But it's not physical, it's all virtual. And when you talk about, when you go to your Google Cloud, or let's do the Azure Cloud, we all have accounts on the Azure Cloud. So even organizations have accounts on the Azure Cloud. They have hardware, dedicated hardware. When you talk about cloud, it's just see it as somebody's laptop, and on that laptop, he has set up multiple VMs. But for them, the hardware they are using is more robust. It's not the kind of processing speed and the processing power it carries is not as what you have for your laptop. It's not an i9. You start seeing, when you go to Azure, if I'm able to do that, you see it. You can see different ways you can spec. You can spec your VMs and the kind of memory you can give it. You want to give it 5 cores. You want to be maybe setting up a 9-core server with 32 gig of memory. With 1 terabyte of hard drive. So all those requests is going to Microsoft, and Microsoft asks for different organizations. So let's say you have the likes of KPMG come and say, I want server. Lagos State government come, I want server. United States government, FBI, everybody's saying I want servers. Different organizations, they come, I want servers. They're able to manage those requests and give you your own environment for you to work with. And guess what? The environment you're working with does not interfere with somebody else's own server. So I won't say, for instance, let me say that was an organization and he has subscribed to our Azure service as Microsoft. So if that is setting up his VM and the likes, there won't be any conflict with the person that is using it in South Africa. He's in Nigeria here. You are setting up your own VMs and you are fine. No conflict. The person in South Africa is also using, in fact, it can be happening at the same time. And there will be no conflict. And that is the beauty of virtualization. You just efficient way of utilizing your hardware. So that is the only way you can sell. So it also affords you the opportunity for you to sell, to consume, to pay for services that you consume. So I just really, is when I need my VM, I turn it on, run whatever I want to run on it, and I'm fine. And it's way of cost saving for you. So imagine if you want to go and set up a data center, you want to set up all your servers and the likes, how much you'll be spending. So Microsoft, like of Microsoft, like of Amazon, the likes of Google, they're saying, see, don't spend that much to go and set up a data center. We have the data center already. Let us sell what we have provided. Let's sell part of our service to you, our hardware. So we just create one for you. You can always use it, run whatever VM you want to run and the likes. I'll draw, let me see if I can use the, come in. If I can use the whiteboard. I believe you can see my screen. So what these cloud providers, what they do is, just like what I used to do OSI layer, these are like a basic layer that you always get for, let me see if I can draw. I really want to use this color. I will still come, I'll just use my PowerPoint for that. So let's go on. So it's just a way of allowing you, the technology allows you to run, to efficiently utilize your physical hardware. And so like I said, each VM runs its own operating system and behaves like an independent computer, even though it is running on just a portion of the underlying computer hardware. So everybody is running his own OS and no conflict anywhere. Do your own, I do my own. Whatever ones you want to run on, you're fine with it. So let's talk what about virtual machines. Like I explained earlier on, they're just virtual computers, and is a virtual environment that simulates a physical computer in a software form. So this day everybody is going to software-defined technology. You get, so it's trying to simulate your physical laptop. So I set up a VM. I have an operating system on it. So it's running like the same way I'm running my physical laptop. So I can try to do a lot of things there. I want to set up my environment. So instead of me, without touching the production environment. So it's a virtual environment. I can do whatever I want to do, create the server, I can destroy the server, I can delete it, and I'll be fine. I can't try that with a production environment. There'll be issue for you. So the virtual machines allows you to play around whatever technology you want to test, whatever concept you want to test, it allows you to test it without any issue. And you can spin it up within seconds. You won't take time. Imagine if you want to do that in a production environment. You don't even need any approval. Just really go and do whatever you want to do. So it has several files containing the VM configuration. So the configuration you have, all the setup you do on your VMs, I want to have we'll see in our answer file, we'll see that it asks me what storage I want to use, what memory I want to use, what project I want to use. And all those information, they are stored in a file. So at any particular time you are starting up your server, your VM, it checks those files and say, okay, what storage am I supposed to run with? What memory am I supposed to run with? And the likes. And you can always have snapshots. That is the beauty of those that are used. Those of us that have heard about the VMware virtualization platform. So you can always create a platform. Let's say I've installed, let's say for instance, I have a VM now, Windows 2012. I've installed an application, or I did some installations on it. And before that installation, I would take a snapshot. Let me give an instance I have. So there's this application that is used for encryption. It's called the Symantec Pgp. So there was a time we were supposed to do an upgrade for it. The version that I was running on it was an older version. So people were having issues. We tried to download a version for the Mac OS users. And so it was giving issues, they couldn't use it. So we asked to upgrade it. We had to reach out to the OEM, and the OEM Symantec in this case says, oh, you guys are running an older version of the PGP server software. You guys need to upgrade it. It's okay, no problem. So I wasn't in infrastructure team. So I reached out to the infrastructure guys. We need to upgrade this thing. And they say, we don't have the time. Well, can you do it on your own? Work with the technical engineer from the OEM and sort it out. So I said, no problem. So when we started, I told the man, let's take a snapshot. In fact, I think it was the infrastructure guy that said, before you can go ahead with any upgrade, take a snapshot, because we have users, and it was a production environment. We have users that are currently using this application, and they are fine. It's because you want to consider new users coming on board, the macOS users. So take a snapshot. So he took a snapshot for us, and he said, let's go ahead. So we went ahead with the upgrade. We were fine with the upgrade. However, there was a step that was missing. There was a file that, I think a certificate file that was meant to be exported from the old version. The OEM didn't remember, it didn't export it. So we've done the upgrade. We're supposed to log into the upgraded version, and it was asking for that certificate. Where's the certificate? If you don't have that certificate, I won't allow you to log in. I can't manage the login authentication process for you. Wow, this was the issue for us. We can't go back. We've upgraded. So what do we need to do? I went to the infrastructure guy. That snapshot you took as at the last working time, let's go back to it. And guess what? Just a click. We went back to the snapshot and everybody was fine. We had the old version of the software back, and it was as if nothing was done. That's the beauty of virtualization. So imagine if there was no snapshot. So snapshot is I'm just taking a picture of, I'm keeping a memory of the way the VM was working before I made any change. So I can always go back to the change. That is the same technology that is being used on your laptop. When they tell you, what's this stuff called? I'm trying to remember it. So on Windows 10, if, let's say, for instance, you have an update on your system, and you take restore time, there's something called about the restore point. It's called a restore point. So it will bring out a restore point for you and say, oh, you did an upgrade on your system, and after that Windows update, your audio is no longer working, the audio driver is corrupt. Do you want to restore to a point earlier than the time before you install the update? You say yes, and it takes you back to that point, and you get all your system working back. Your system functioning the same way it was functioning before that update. So it's just a way of you to go back. If you have missed your step, you are using Google Map, and you intended to go to Ikeja. You didn't follow the map very well, and the map is taking you to Ojota. So what do? Find a way to go back. If you don't know where you're going to, then go back. So that is the same technology that VM does for you. It tells you to take snapshots. If you have, at any point in time, you have issues, you can always go back to the last working time and you'll be fine. And so for virtual machines to do all these things they're able to do, are you able to manage your virtual machines? It's done by a software that is called Hypervisor. And so the coordination of your VMs, if that an hypervisor, you can't coordinate your VMs. You can't simulate a virtual environment on your hardware without that hypervisor. It's the same thing that what's it called? Let me see if I can create a slide here. So let me come here. Sorry, I tried to create. This is not what I want. Hold on.
Hello.
Yeah, Dapo. Yeah, hold on. I want to do something. Hold on.
Okay. Yeah, Liman, your hand is raised. Do you have a question?
So
Hello.
I want to make an explanation here so that's why I'm coming here. I'll still expand my screen too. Just see it. Just give it some time. So So this is your environment in the cloud. For Microsoft, what they've done for you is, regardless of what you have, everybody is running this. You get this just like, I'll call like the similitude of the OSI layer you have for in IT world. You get, when you are doing networking, they will teach about the OSI layer, the different layers you have. So for the cloud, you have, as a user, you have data, you have application, you have runtime, you have operating system, you have the hypervisor, you have compute, network, and storage. And this is just trying to explain the different types of the cloud architecture that we have. Many of us have heard about IaaS, infrastructure as a service. You'd have heard about platform as a service, the PaaS. And so change the color first. So this is for you as the, can you see my screen? I'll do something now. All right. Just a minute, just to explain some things to us. So you have your private cloud. That's fine now. So this infrastructure as a service. And this is where you have platform as a service. All right. Yeah, I think I'm good now. So I believe you can see my screen, right? So when you look at the architecture, as a consumer, you have data, you have application, you have the runtime, you have operating system. In your private cloud, you are trying to say, all this, I want to cater for it. I don't want anybody to handle it for me. So that's what you guys do. That's what your infrastructure guys, they do for you in your organization. Everything about the compute, the network, the storage, everything is handled. Those of us that have what you would call the sysadmin in your team, or infrastructure guys in your team, infrastructure team. So they have VMs, they spin for you. They have a VMware VMs that is spin for you. I need a server. You do whatever you want to apply, you apply to them and they approve it and they give you a server. So they're able to create those servers using hypervisor. Without hypervisor, they can't create those servers for you. For your IIS, that is infrastructure as a service. So what happens is Microsoft, Amazon, or Google, they take care of compute, take care of network, they take care of storage. And they have the hypervisor and say, don't worry, on our hypervisor, you can create your operating system. And that's what we'll be doing in some minutes to come. Whatever operating system you want to use, whether it is Linux, whether it is Windows, you set it up on your own. They don't interfere with it. So you are responsible for the patching, you are responsible for updating it, whatever happens to it is handled by you. Whatever application you want to put on it, you are fine. No issue. Whatever data you want to store on it, that is your own business. But what they handle, what they are responsible for is they take care of the storage and say, don't worry about the storage. We'll tell you whatever storage you want, Taylor will make it available for you. Whatever network you want, your VNet will give it to you. Or your compute, how you want it, we'll also give it to you, no issue about it. The processor you want and the likes, the memory you want to use. And it's running on the own hypervisor. So they're able to do that because there's an hypervisor. Without it, you can't create all those things. So that's the technology, that's the software that allows you to create an abstraction layer over your hardware. And for your platform as a service, they handle everything about the operating system. That imagine like the likes of, maybe they give you a SQL Server platform. And so all you're bringing into that platform is just your data and your application, whatever application you want to, they've set it up for you. All you're just bringing in is your data and application. The runtime, the operating system, the hypervisor, everything is handled by the cloud provider. So the application is your own, the data is your own. You ensure it's your own responsibility. Just trying to explain to you. And to let you know that without hypervisor, as a cloud provider, I can't allow my users or my customers will not be able to create VMs. And me, as an owner, I can't create VMs without hypervisors. And this is what I'm trying to explain to us. So you can see this is your physical machine. You have CPU, you have RAM, you have the network card, you have your storage, your hard drive, and you have an operating system. Can you all see the screen? So you have an operating system. And so this is where your physical machine is set up. On my laptop, I have an OS. If I have a laptop without OS, there's nothing I can do with it. It's just an hardware I have. So like I told us about the operating system, is what handles your interaction within the hardware and you as the end user. So your application runs on your operating system. If there's no operating system, I can't download Zoom and install. If there's no operating system, you can't download VirtualBox. Your VirtualBox, the likes of hypervisor we have, sorry. I was supposed to talk about the types of hypervisor. So we have the bare metal hypervisor, and that is called the type 1 hypervisor. What it does there is you are installing the hypervisor on the physical device. So it means the hypervisor itself is acting like an operating system, similar to what you have for the likes of VMware or like an Avaya server and the likes. So they are giving you the hypervisor. It is installed on a hardware, and without any OS coming in between as an interface or as a layer. those ones are called, short kind of hypervisors, they are called the type 1 hypervisors. And I gave us the instance of your Google Cloud, your Azure Cloud. They have hypervisors. There's nothing that is coming in, there's no OS coming in between. The OS is now you. You now run your OS on the hypervisors. So such kind of ones that are called the type 1 hypervisors. And even, I think Microsoft also, they have, you can install hypervisor on it. They have hypervisors running as a server, hypervisor servers. So those ones don't need any OS running, it's just the hypervisors. You cannot bring in your VMs, whatever VMs you want to bring on it, on the hypervisor. It's seen on that layer. So for your type 2, the type 2 is what most of us apply this, the whole practice. Your virtual boss is doing a type 2 hypervisor. Your VMware manager is doing a VMware player, your player or your, so he's all doing it, he's doing hypervisor. Your App-IV in Microsoft, they're all type 2 hypervisors. Why are they type 2 hypervisors? Because of, they can't run without an operating system. They require an operating system to come in as a layer. You see it? So they are commonly used on endpoint devices, like your laptop, to run an alternative operating system so that they can carry a performance overhead, because they must use the host OS to access and coordinate the underlying hardware resources. So I need an hypervisor installed on an host OS. There must be an host OS. For the type 1, there's no host OS. The hypervisor is sitting on the physical hardware itself. For type 2, you need an OS hosted by the host. And that's why you now talk about the host OS and the guest OS. And there are times you can hear people calling your type 2 hypervisors, they call them the hosted hypervisors. Hosted in the sense that you need an host OS. If there's no host OS, you can't run it. So imagine I have VirtualBox and I just download that, say I want to run VMs. I can't download VirtualBox and install without an OS. There's an OS I'm running on, whether I'm running on Windows 10, Windows 11, or I'm running on a Linux. Like somebody told us, I think on the platform, the Discord platform, that it has Linux. So you need an OS, regardless of whatever OS it is, for you to be able to host your type 2 hypervisors. They are hosted. They can't run on their own. They need OS to host them. But for the type 1 hypervisors, they don't need any OS. They just run on their own. They say they are like OS. And you can, from them, create VMs. And so this is your physical machine. You have your CPU, you have your RAM, you have your network, you have your storage. For virtual machine, this is just a picture explaining what your type 2 hypervisor does. So I want to use this CPU RAM storage that I have to create VMs. And so you can see you have, here I have three VMs on one particular virtual machine, multiple OS. And on this OS, the virtual machine has its own OS and runs its own application. So I'm just distributing my resources across different VMs. And so you can see the difference. The first one, the traditional operating system can be an hypervisor directly on the hardware. So for the type 2, you have an hypervisor on an OS. And on that OS, because this is like a type 1, sorry. This is like a type 1 because the hypervisor is sitting on the hardware. It's not, there's no OS in between the hypervisor and the computer hardware or the physical hardware. So for the type 2, you have an OS sitting in between the hypervisor and the hardware. So the hypervisor will sit on your OS, and you cannot create other virtual machines on the hypervisor, install whatever OS you want to install whatever application on the OS, and you'll be fine. So thank you. This is where we'll stop for. Do you have any question on the theoretical part of it? So once you go and create our VMs now, I'm going to the virtual box. There's a question, somebody is asking me a question. Let me just check, sorry.
Okay, hello, can you hear me?
Yeah, I'm reading the question.
Okay.
So someone is asking, so does my local machine HP with Windows 10 already have an hypervisor, or do I have to personally install type 2 on my local machine? So what we are saying is your type 2, your local machine it has an OS. For you to be able to run virtual machines, you need to install an hypervisor, which is your, you can see my here, which is your virtual bus. This is my hypervisor that I'm using, the virtual bus, and you can see the servers I've set up on them. So you have your virtual bus installed on it. If the virtual bus is not installed on it, you can't run anything. If the virtual bus is not installed on it, you can't run anything. You can't virtualize your physical laptop. So you need a virtual bus installed on it. And Windows 10 comes with an hypervisor that is called Hyper-V. It's called Hyper-V. So to start up, so that you'll be mindful of, there are some challenges that you might likely face. I'm coming, let me just run something for us. So many of us might not just go to you just want to set up a virtual bus and you're fine. I'm going to set up a VMware player and I'm fine. You need to check, there are some settings that you must turn on. There are some settings that must be turned on. Yeah, can you hear me?
Sorry, I had network issue for over 10 minutes, so sorry. Have you installed the virtual box?
So I've installed my virtual box.
Okay, which I've done. Okay, what about setting up the VM? Have you done the setting up of the VM?
I'll create one for us now. So this is...
Okay, I just want to know what I missed.
You've not missed too much. So I'm just starting the hands-on class. So this is your virtual box download. Just come to your Google, like I told us, this is a web interface. Virtual box download, you just click on it. Let me stop this. So you can see you have different hosts. I told you you need host OS. Without the host OS, you cannot run the type 2 hypervisor. You need the host OS. So it's asking what OS are you using? Are you using a Windows OS? Are you using OS X, which is your Mac? Are you using a Linux? Are you using Solaris? You need to get one OS for it to be able to install. So just install it. The reason why I'm using virtual, I would have done VMware player, but you don't get the full feature. You have to get a licensed version. That is your VMware workstation. Its license is not free. You have to pay for it. So just to save you of that cost, that's why I'm using VirtualBox. This is open source. It's free. You don't need to pay anything to download it. It's free. You can download it and start installing. All you just need to do, there's updates because there will always be changes. People are trying to add new features to it. So you just get your VirtualBox updated. And when you run it, it prompts if you want to run an updated version. You just apply the updated version and you'll be fine. So that's that about downloading. So I was talking about challenge you're likely to face. So this is my VirtualBox. And what I need to do is, somebody was asking if I'm going to demo the snapshot. I'll show you a snapshot now. So this is new. You come to a new machine and say new. And it tells you what type of VM do you want to create? Is it a Microsoft Windows? Is it Linux? Is it Solaris? Is it IBM? Is it macOS? So it's asking you need to know what type of OS. A lot like I told us, we have different OS. It's not just Microsoft OS we have or Windows OS we have. But for us today, we're doing the Windows OS.
Hello.
And Windows OS has different versions.
Sorry, bro. Sorry for cutting you short. The application, yeah, I've downloaded the VirtualBox, but I haven't installed it. Should I go ahead and install it so that I can follow up with you?
Yes, actually, go ahead and install it.
Oh, okay, cool. Thank you.
Go ahead and install it. So let me just take some things if I go to just to buy time while it's trying to install. So you come to your control panel, you might get some challenges while you are trying to install, telling you that you need to enable virtualization terminal VT. So you click on programs and features. So you see turn on Windows features. You get? And so there's a feature that has to be turned on. If it's not turned on, you might be having a challenge. When you install and try to create VMs, it might not allow you to create VMs. It will be returning error for you because of, you can see, there's this virtual machine platform that you need to install. There's a VT. So for the person that wants to, if you want to use Hyper-V on Windows, all you need to do is you check your Hyper-V. You just check this one. Once you check it, you'll be fine. You'll be fine, and you'll be able to set up your virtual box on it. And this is not what I want to show. Apart from this one, so you might need to turn on virtualization apart from that of control panel on the Windows features. I want to show something on when you have an issue, it might tell you don't have. So can you see this? Can you see this? So in setting up, you might get an error telling you that virtualization is not turned on, so you can't create VMs. If you are getting that error, come and check. Just go to your control panel and see. You can see it's enabled, and the only way you can enable it is from your BIOS. You need to go to your BIOS and enable your VM and virtualization. There is something called virtualization TS on your BIOS. Just go to advanced settings, you see virtualization TS, then click on turn on, enable it. If you have issues, we can always take that on the Discord, just because of time, so that we can quickly set up what we need to set up. So this is my virtual machine. I have Linux operating system already running that I've created on it. I have this. So you can see, all I just need to do is to do snapshots. I can do a snapshot for it. So this is the current state. So it has taken it. I will just tell it, take it. And name it whatever thing I want to. Let me say, I've not installed the WS. So I cannot say before IIS install. So at any point in time, you can want to go and start from this state. You can tell it to start from this state, or you can even take a clone of it. You can clone. I can take clone of this server, and I'll be fine. So I had issue. I created this one earlier on, but I had issue with it. So I can tell it to run from here. So you can see the state I'm running from. Now I want to run from this particular state. So whatever change I've done before this state will be overridden, then I'll be fine here. So the reason why I'm getting is because I have a CD that is inserted. There's a virtual CD-ROM that is inserted. So for you to work, just do use your keyboard. For you to just, instead of to press Control Delete, what you need to do is go to your menu, you see inputs. These are your inputs. So just come to input keyboard commands. You want to enter keyboard commands. I want to enter Control Delete. But I can't remember. Let me hide this. Can I hide this? Okay, so I've forgotten this password. I can't enter into it. So what I need to do is I will delete it. And that's the beauty of virtual machine. I try to close it. It tells me I want to shut down. Yes, I want to power it off. You can see. Can you see this? The person that was asking about snapshot, can you see it? Hello?
Yes, I can see it.
Yeah, so let's say before now I have issue with this particular server. So it's telling me that I can see you've created a snapshot. Do you want to restore your server from that point? So this is a particular point. So whatever changes I've made, which will be ignored, it will now restore to this particular point and I'll be fine. And that is the beauty of snapshot. It's just taking, like the word sounds, like maybe you're taking a photo of the state of the machine as at the particular point in time. The state of the machine is taken and is kept in memory for you. So that if you want to go back at any point in time, you can always go back to that snapshot. But I want to shut it down. I don't want to restore any snapshots. I'm shutting it down. I can't remember the password. So if you want to delete a server, all you need to just do is just do remove and delete all files, and you'll be fine. So because of time, I will just show you what you need to do. So you just do new machine, new, then you select Windows, Microsoft Windows. What version of OS do you want to do? So let's say 2019. I have 2012. I have 2019. So you just say 2019. You select, and mind you, we have for Windows OS version, we have 64-bit, and most these days now for operating system, the OEMs are trying to just stick with 64-bit because of limitations you have with 32-bit. So most OS that are coming out now, they are done on 64-bit and not 32-bit anymore. Even though some old ones might have 32-bit, older versions of operating system have 32-bit. But you see, going forward from 2012, it started doing 64-bit, nothing like 32-bit. So that's the reason why you might have 32-bit and 64-bit. So you select so you give it a name. You give it a name. Let me just call it as NG1, and I do next. And it's asking for the memory size. So the memory is a function of what memory I have. I have 16 gig on my system. You can see. It's saying I can see you have 16 gig as a physical memory. So what memory do you want to assign to your server? I'll pick the memory size. I can make it 4. But I want to do it 2 gig. Then create a virtual hard drive. Yes, create a virtual hard drive. Then, so you're saying you want to use a VirtualBox disk image or a virtual hard drive. Just do a virtual drive. If I use a VirtualBox disk image, I can export this VM, take it to another laptop, and run VM on that, and run VirtualBox on that laptop, and I'll be able to run that VM on that laptop. So whatever settings I have on my laptop, I can export it to another laptop and run that VM from that laptop. The beauty of virtualization. Or a virtual hard drive. If I do a virtual hard drive, I can attach this hard drive to a physical laptop and it will run. So that is just the beauty. So depending on which one you want to do. The VMDK is if you are using a VMware machine disk. So you are using a VMware machine disk, or you want to use a virtual hard drive that you can attach to a physical laptop, or you want to use a VirtualBox this image. So let me use the VirtualBox this image. So dynamically allocated, meaning as the size of my application, the application I install on it, as I start allocating more files, it can increase the size. Yeah, I'm using 50 gig, can increase it to more than 50 gig. And so this is the name I've given it. So you can see the storage I'm using. So you're saying what storage you want to assign to it. I'm just giving it 50 gig, then I'll be fine. So at this point, you've not installed any OS. Remember, I told you your server can't run without an OS. You've not installed any OS. So what you need to do is to come to settings. You come to your storage. And if you see the storage, you can see that I have a drive, but I don't have a disk. So that means I'm talking about the CD-ROM or DVD-ROM disk. So it's asking you, how do you want to run this OS? Where will you get the OS you want to install? If it was a physical server or a physical laptop, I would have inserted my flash drive, bootable flash drive to install the OS from it. But there's a provision for you. So all you just need to do is go to Microsoft's website. You can download an evaluation copy of servers just for 6 months. So you don't need to license it for 6 months. You can use it after 6 months, it's disabled. So you can download it. I have already downloaded mine. So I will just go have it on my system. So see, I have 2019, I have 2012. This is 2022, which I have. So you just select them. You can see because I have it on the system. But if you have not seen it, let's say you have downloaded it, you've not used it on VirtualBox, you need to choose the disk file and navigate to where you have it, whether on your download folder or your documents, navigate to it. So let's say I want to pick 2019. This is my 2019. This is the size. So you can see the location where I have it. So I'll do OK. Now I'll tell it to run. So I'm not going to take this. I already have my setup. I've already set up my server. So I won't allow us to go through this. I'm just explaining to us so that you can understand how you create your VMs and how you can install your OS on your VMs. So you can see it's booting from the virtual disk. It's an ISO file I've downloaded. So this is, you can see, like I told us, it's a Windows Server 2019. You can leave this as default, or you can change your inputs, keyboard inputs. And you do next, you do install now.
Sorry,
so
where did you get that image from?
You download it on the internet from Microsoft website. Yes.
And is it a licensed image?
Copy. You see what?
Is it a licensed image, or is that expiry date?
No, it's not licensed. It's an evaluation copy. You can see it.
For 30 days.
Evaluation copy. So for 6 months, you can use it. Okay. It's just for 6 months.
6 months, okay.
Yeah, and it comes with all the features of the licensed server. It's just that it's just for temporary, for 6 month evaluation. After 6 months, you're off. So what Microsoft do is when they create new OS, they give you a version that you can try to test, like doing a POC. Use all the features and see. If you don't like it, nobody wants you to come and pay after your POC. Except you want to now buy a license. So I want to buy the license, I'll finish my POC. Then you can now pay. But if you're not paying, after your POC, you can just decommission whatever server they've given you and you're fine. So for Windows servers, you always have 2 versions. You have the standard or the data center. Standard has a limited option for virtualization. It's just minimal way of applying the virtualization features. For data center, and it's just more of like a single user. But for data center, it's a robust feature where you can optimize the use of your virtualization with data center. So standard version is just limited, maybe just small office environment. But when you're talking of enterprise, you use your data center. So you can just select the one you want. If you are doing evaluation, so the first one is, if you are using 2012, there is core installation and there is GUI installation. So, but for 2019, instead of saying core, they just call it standard. But if you are doing this Windows Server 2019 standard, it should be purely command line. It's core. Core means it's command line. There is no GUI. If you are logging onto the server, you manage it from a command line prompt. You don't see a GUI. But if you are doing desktop experience, that is where you will see the GUI. You now log on, you can see your server manager and everything. And that's what I'm going to. So I just did this one. You guys will be having a task to do. You are going to set up your own server. You will name it after your own team. You can see I'm having DNS and daas.ng cloud, daas.ng agile. I just did that for us so that we can just know how you set up your VM and how you install it and you manage installation. So I will not go there. I will just turn off this one. So let us go because of time. So I have my VM already set up.
Okay, sir, just a quick question, sir. Can we say a type 1 hypervisor is physical and type 2 hypervisor is virtual?
Okay, so for your type 1 is installed on a physical, yeah, you can say virtual. Type 1 is installed on a physical system. You get, it's on a physical system. But for type 2, you have to install it on an OS. You get, you can see my VirtualBox now. I have to install it on an operating system, Windows 10 operating system. I can't run it without installing it. It needs an OS. So all the VMs I'm going to be running, they'll be running as guest OS. They are running as guest OS. They have a guest OS. But for hypervisor, it's an OS on it. So the type 1 hypervisor is an OS on its own. So you're not installing it on an operating system, maybe Windows 10. You are installing it on a physical server. Do you get? So that's what you will have for your VMware. Those of us that you talk to your sysadmin team, you talk to your infrastructure team, I need a server. As a developer, you might just tell you, oh, or even people coming to you as a DevOps engineer, they're not coming to you and say, developers are coming to you and say, DevOps engineer, please, I need a server of this particular spec, 16 gig, 512, 5 cores, and the likes. Let me spin it up. So you're able to spin up those VMs because of there is a server in your data center where they've installed the VMware hypervisor on. And so with that, you can now create VMs and you'll be fine. Or you're not using VMware, you have your Azure cloud or you have your AWS cloud. So AWS has given you an hypervisor, which you don't see it, you're not seeing it. But that hypervisor is installed on their own physical hardware. You get? It's installed on physical. So whatever you are running, whatever VMs you are creating it on their own physical hardware, which you don't see. It's in a data center somewhere. You see, they will tell you, when you are creating your VMs on Azure Cloud, they will tell you which data center do you want. Is it North America? Is it East US, West US? Is it South Africa? I think Microsoft now have a data center in South Africa. Is it South Africa? Is it Europe? Is it Asia? And the like. So, because they have it there physically on a data center, but you are accessing it on a virtual platform. But the hypervisor is on a physical device. I hope that is clear. Yeah, because of time, I have limited time to quickly demo this.
So we've been talking about virtualization. Where does containers come?
So container is still driving on the virtualization technology, but the only difference is that they are all the virtual environments. They are running them on an isolated environment. All your dependencies, they are put together in one isolated environment. So it tries to reach the same feature like you have for your VMs. I have different VMs running and they don't get to interfere with each other. So you can have different containers on a particular cluster, and they are not, or even on a node, on a node of a cluster, and they are not interacting they are not interfering with each other. I have a container that has this application here for me, another container has application too. I want to run multiple instances of one particular application. So I have 4 containers and they're running different instances. So it's one instance per container, and all the dependencies are put together, they are packaged together such that that container can run from anywhere. Do you get? Different from your virtualization, your hypervisor, in the sense that for my hypervisor, I can't take, if I'm installing now containers are not, they are, what do I call it? They are environment agnostic. So it's not asking you that, do you want to do it on Mac OS? Do you want to do it on Windows? Do you want to know? Once it's a container, as long as you have, you're using Kubernetes, you're even Docker, you can run it from anywhere. But for virtualization now, you have to start, which OS do you want to use? What host will host you? What OS will host you? Is it the Windows that host you? Is it Linux that host you and the likes? Do you get? We'll still talk more about that. When we come to containerization and Kubernetes, you'll still see more of it and you get to understand it. Different between containers and your VMs. For VMs are resource intensive. You can see now, they are resource intensive. I have to give it a memory, I have to give it, but for containers, it's they are very flexible, very light. It doesn't consume too much of resources. So you can have multiple split together and within seconds, and you'll be fine. We'll still demo on that one. Let me just quickly run. So I have my password. Yeah, so we're good. So you can see. Can you see what I told us? He's telling me that I have an annihilation. This is 6 months, 180 days. You get, so 30 times 6, 180 days. So I have, it's an evaluation copy I'm running, it's not licensed. When I have the licensed version, they will show this for me. So So there's a server manager dashboard that you have. And there's a new feature that was introduced from 2016. And that feature is called the Windows Admin Center. What this Windows Admin Center does for you is allows you to be able to manage your server from the web, from a browser. So I can go into a browser and log into it. Some of us that have that experience. So I can go into a browser and log into my server without using a remote terminal. But for this one, so I've set it up. I'm not looking at that for today because of time. In our class, in our hands-on class for Wednesday, we might go into that one. So you can see, I have my dashboard. This is my server manager. It helps you to manage everything about your server. And there are tools here, so you can see. Compute management, I want to defragment it, I want to disk clean up. So you can see print manager and the likes. These are different options. Whatever tool you want to make use of it, it will tell you, go to that tool and you pick it up. So if you do manage, you come to manage all those roles I was telling you about. So you tell you add roles and features. So this is the beginning page. So what kind of feature are you installing? Is a role-based feature, you can see. Or remote. I want to do it on a remote system or on a virtual infrastructure. So he's saying I want to do it here. It's role-based. And he's asking me what server I want to pick. This is my server. You can see an IP address has been assigned to my server already. You can see the IP. Because of my virtual bus, I applied something called NAT. There are different options for your networking. You can also do it on Wednesday. I'm just trying to rush because of time. So you can do a bridge adapter, you can do a NAT adapter. If you are doing a NAT adapter, it will translate your physical IP to a different IP. You get? So I'll still come back to this one. So we come to a local server. This is my server now. This is the server I have. I've set up a server. I don't have any role on it yet. I've not told it what it should be, whether it should be a DNS server, whether I should have an AD server, whether I should have a DHCP server role, whether I should have a web server role or IIS server role. I've not given it any role, which is just the information about my server. So the first, one of the tasks will be, you guys will need to change the computer name. You can see it. You need to change the computer name and give it a different computer name. So you might just say Agile Team. So this is the computer name. I want to change it to Agile Team. You get, so you can join into a work group if you have a domain. I don't have a domain yet, so I just keep to a work group yet. Domain, that's when you want to now make it a domain controller. You pick a default domain you want to use. Work group. I'm not going to restart it so that it doesn't. So it requires you to restart for you to apply that name. So I'll tell you restart later. Once you restart and it comes up, you will see this computer name will change. So it's best practice that you always change the computer name of your server. So that when I'm logging on, that is the name that will show. I don't want to start seeing anything like Win, whatever. This is also a generic name that is generated by Windows. So I don't want a generic name. I want to give it a particular name. So once I see it, I say, okay, I want to use this as a DNS server, or I want to use it as my web server. Once I do that, I'll be fine. So once I see the server name, I know what server it is. Other than having a generic name, it becomes difficult to start identifying what server you are trying to log on to. Then we talk about the IP addressing part. I told you that we talk about how to assign IP address to it. And so this is your network adapter. This system is picking the network adapter of this is a virtual network adapter. It has a network adapter because my physical machine has it. So it's trying to simulate what I have on the physical. I know I told us about compute, network, and storage. So it's distributing it and it has given this VM an adapter. So I have to assign an IP address to it. You can see for IP addressing, we have two options. You can make it a static mode or dynamic mode. Currently it's on dynamic mode. That's why you can see DHCP enabled. It's saying yes. If I assign a static IP to it, it becomes no. You can see this is my physical address that you always call the MAC address. So for those in the security end, they will always tell you, I need the MAC address of your server, I need the IP address. You can tie your MAC address and IP address together. And when you do that, you can apply some controls. You can put some controls, you can put some permissions with that. You get. So the reason why people most times try to go in the way of MAC address is because of MAC address it doesn't change. The MAC address of a system doesn't change. Ideally, it's not expected to change. But your IP can always change. So if I make it dynamic now, for any reason it can change. Maybe by the time I was off the network, another system has been assigned this IP. By the time you're coming up on network again, you will notice that a different IP will be assigned to you, different from what you had initially. So this is the option of DHCP. So you can see my DNS. Can you see my DNS server?
Yes.
What is the DNS server?
Yes, you can see it.
192.168.0.1. So this is the IP address that my network and service, my ISP has given to me. Ideally, what I should have been seeing here is 192.168.0.164 whatever or .15. But because I applied the bridge the NAT option for my networking, for my network configuration on my virtual bus, so that's why it has NATed it, it has translated it, it's giving me a different IP. It has mapped it to a different IP so that you can see a private IP it has given to me. So we have three classes of IP addressing. We have class A, class B, class C. Your class A starts with 1 to 126. Any range between your 10 dot is a class A IP addressing class. Your class B starts with 128 to 191. Because of your 127 is your local host. By default, your local host has been assigned an IP address which is 127.0.0.1. And class C is a 192. This one now you can see it for public. Public is having 192 to 254. So I can see, once I see 192, I know it's a public IP that I'm using. So this is the public IP for my ISP that they've given to me. So you are going to change the IP address. You just come to properties. You come to Internet Protocol version 4. We know we have two version protocols. We have IPv6 and IPv4. But you just do IPv4, then you put in the IP address you want to give it. Whatever IP you give it, that's the IP the server will work on. You get, and the subnet max 255.255. This is a class C subnet max. Your default gateway 192.168.0.1. You get, then maybe we'll have a class where I will teach you guys about IP addressing. Now, when we are doing the networking part of our mentoring session, they'll teach about the IP addressing. And for my DNS server, I can choose to use the Google DNS server, which is 8.8.8.8. So what the DNS server does for you is that it tries to do what we call, somebody mentioned it in a class, that DNS, domain name service. So what it's doing for you is trying to resolve, is mapping your IP to a name. So when you say google.com, you don't want to know the IP. Google is running on an IP, but it will be difficult. You can't put all IPs in your head. It's easier to have name than IP. So you can see this is the IP of Google. 142.252.250.200.46. If I go to this IP, So you can see, can you see it? Can you see it? So the reason why is able to, I entered an IP, but it has translated it and it's telling me that this IP you enter is for Google. Do you see it? So it has taken me to the Google server, web server, and sent that IP. So instead of giving you IP, it has taken that IP and said this IP I've given you is mapped to a name called Google. So that's what the DNS server does for you. It's just a directory of IP address mapped to a name. So maybe in your environment, you have different IPs. You say that's one, that's DNS, that's webmail, that's file server. It has an IP address. So on your DNS server, you just configure that. So when you see that's file server, this is the IP that is linked to it. So that whoever that is going there, we just, once you send a request, once I enter my IP address, the DNS server tells, the system goes to the DNS server and query it and say, please, this IP belongs to which server? And you say, oh, this is the DAS webmail server. And it goes to that server and you're fine. You can access it. So now you know the IP or you know the computer name. So this is that about IP addressing and the feature you have, your time zone. So you can see, I'm using an i5 laptop. So you can see, I told you, it's going to emulate whatever you have. It's picking whatever you have as your physical server. So it's picking my VM as an i5. This is the space I created for it, storage space. This is the memory I created for it. So let me just quickly, my bosses are telling me that I need to go now. I've spent too much time. So let's create a role quickly. I'll just create a web server role, IIS server. So you just do next, role base. So select, this is the server. Ideally, you can have a cluster of servers and just pick the particular server you want on that cluster. But this is only one server I have. So I've selected it. And so it's telling me, what do you want to do? Do you want to do a file? You know, already you can see what has been installed. By default, the operating system comes with a file storage service role installed already. So I'll just tell it, I want an IIS server. You can see web server. That's what I want to be installed. And add this feature. So when you're adding a feature, I wanted to show something there. Okay. So once I select IIS server, then of course you need a .NET frame for it to work. Then I do next. Just based on our defaults, that was telling us about web servers that you always go through HTTP, of course, port 80 or port 443, that is for HTTPS. So it does a summary of what will be installed, the feature that will be installed. Then I do install.
So we have actually created a web server, right?
Yes.
Okay.
So it will take a while to install. So installing the features.
Once the physical machine shuts down, all the virtual servers are going to shut down, I guess.
Yes, you are correct. So that's the difference. That's another difference between your physical machine and your type 1 and type 2. For type 1, they can't go down. Google cannot go down. You get? So if the data center that somebody was talking about HA, high availability, the data center that you are going from, the data center that are connecting from, if it goes down, they have several of those data centers that you can run from again. They will just, without you knowing, they will just reroute you to a different data center. So you have availability zones, something called availability zone. So it just take you, this particular zone is down, let's take it to another particular zone, and you start running from there. So you can see that's finished install. Okay. It's almost done, it's not yet done. So the task that I'm going to give us is, you are going to create a web server, an IIS server. You deploy a web service to it, web API to that server. So you can see. Can you see now? So it's showing you the servers I have now. I have a file storage service running. I have an IIS server. Can you see it?
Or you didn't show us how to deploy a web service APIs.
So that's the reason why you need to go and do more work. We'll do more on that. So this is my IIS server that I've installed. So you need a server manager. So this is the IIS service manager. So I go there. So you can see it. So this is my site. So the default site, I can browse to the default site. You can see that it's HTTP. On Wednesday, I think that will take us on that. I'll join the session also. We'll teach how you create, how you can deploy web service to your IIS server, how you can create a certificate, a self-signed certificate to it, apply that certificate. That certificate so that it will not be showing HTTP, it will be showing HTTPS. Secure, it will be a secure site. Can you see the locale? So once I have this, it means I'm fine.
Hello, can you hear me?
Please, can we have this recording?
Yes, you have it. We'll upload it after the class. We'll upload it. So you have your local host. I was telling you about 127.0.0.1. You see it, it's the same thing. So the reason why you have that is because of, let me show you something.
Hello, Sean, can you hear me?
Yeah, I can hear you.
Yeah, please try and round up, please.
All right, so this is where we'll end our session for the hands-on class. I've been able to take us through how you set up your server and how you create roles. In creating roles, all you just need to do is to come to your manage and do hard roles. You can have all those, your DNS server, DHCP servers, file server, web server, they're all roles on your servers. You can have them. So you can even create as much, you can create as much as 3 VMs and have different roles for each of those VMs. You get. But for this one, I've decided to put my IIS server on my own VM. And I'll show you how you can change the computer name and also assign an IP address to it. So it does review the video. Once you upload it, if you have any challenge, you can always reach out to us on the Discord channel. We're available to attend to all your questions and whatever clarifications that you need. And I'll stop here. So I'll shut down my server. I'm done. I want to shut it down. And one good thing about server is before you shut down, it tells you why are you shutting me down. Give me a reason why you're shutting down. Do you have a planned maintenance or is it an hardware maintenance or whatever? And it's going to keep that in the log. So it's shut down. Yes. So thank you very much for your time. This is where we'll stop because of time. Would have gone longer than this, but because of time, and so that we can also attend to all the personal things that we have. So we're stopping here.
All right, Sean, thank you so much for the expository teaching on server administration and virtualization. So quickly, we'll just take questions. I think we have people that have their hands raised. So please quickly unmute and ask your questions. Hello. Please, can you?
Hello, sir.
Yes, please go ahead.
Mr. Sean, thank you for the presentation. I appreciate your commitment and your devotion towards this. So I wanted to ask, since you have already shut down the server, but I want to ask, can you change the default website, the DNS of the default websites that is attached to your server?
The what? The DNS? Did you say DNS?
Yes, the DNS.
Yeah, you can say whatever DNS you want. Whatever DNS you want to point to it, you can even have multiple DNS pointing to it. So I can choose to do that of my ISP and pick that of Google. Google is because it's global, it's over the internet, so that it's not limited. You have a large collection of servers mapped to an IP. So that's the only disadvantage you might have. If you pick a DNS server that is not global, you might have some site that you cannot reach out to.
Okay. So also, can you also restrict it? And I know that you discussed about restricting people connecting directly to the internet as an organization base. There is only local connection, maybe to the database system that is being set up in the organization. Then you can now, can you also now network or connect to the internet in case they need to use the internet? Is it possible
so what you
to
don't
use
do is, when I mentioned, I was explaining about proxy server. And so what proxy server does, there's something called exception lists. So exception list is saying, if you are going to the internet, these particular applications, they don't need to go to the internet on your proxy servers and say every other request. So you can bypass some requests and say you don't need to go through the proxy to get to the internet. You can just go directly. And there are some you say, no, if you must go to the internet, you must pass through your proxy. And on that proxy, there are restrictions, there are permissions that have been applied on your proxy server and saying, we have some applications that can talk to the internet. We have some that cannot talk. So they're only in-house. So if you have applied some permissions and saying this particular application doesn't have any business to go inside to the internet because we are hosting it in-house. You don't need to go to the internet. Let's say your email now, your Microsoft Teams is in-house and Microsoft is on the internet, is in the cloud. And so whoever is using that application, you allow them to go to the internet. And you know, there are some users, depending on the restriction you're talking about, there are some users that you don't have internet permission. So if that kind of a user now is trying to go on Microsoft Teams, you might be having an issue because Teams need to go to the internet, but the user doesn't have an internet, his profile does not allow internet access. That person will be having issues, except you apply internet access. And that is the reason why you have OUs, so your OU is also able to manage permissions, manage access, and say, okay, I have an OU I can call that OU folder. That is where you have your AD. We still have the class on that on one of our Wednesdays. So you have your OU and you put internet users. Whoever is not on that OU, you cannot access internet. So you just apply people you want to have access to internet and you put them there. So once you're online, you're okay. So if somebody calls and said, I don't have internet access, what is happening? They can always go and check. We applied it for you now. So you can go and check, is that person still on that OU or the person has been removed from that OU? Is that clear?
Okay, sir. But if they have designed a website for that purpose, if they design their own website and you can land or give maybe like a bank system, as you said, maybe individual persons in different organizations already built a website and maybe their database systems is logged into their website and they need to do maintenance or access going beyond, maybe using their website as a default website, website listing.
So what you do as administrators, what administrator does is, it's not best practice to expose your servers to the internet. There are different approaches to it, you get. So what they just do is, if you want, like there's something that is called the DMZ zone. DMZ zone is saying you don't go to the internet directly. I have like a firewall that will manage your connection to the internet. Or at times, it might be saying you have a deny policy. If you are going to the internet, you are not allowed. So for instance, maybe you need to update the server and you need internet access. You can have a permission granted to it and say, okay, for this particular period of time, I will give you an access rule to go to the internet, do the update, and after that, I'll disable it. You get, so at that point in time, the server can be, but this is you as a server administrator. So at that point in time, you can apply update on the server, and once it's done, that port is shut down. You know, when it comes to servers, they all have ports they communicate through. we are going to talk about that one. Your RDP port, you have your HTTP port, port 80, port 443. There's a port that your servers must communicate through. If those ports are not permitted, you have issues. When you set up your web server in that class, I'll take you through something there. I was to explain port, how you can change the ports. So you can, the default site we have, you can have more sites. You can add more sites and referencing different index files and applying different ports to them and say, okay, I don't want you to go through port 80, go through port 8080, or don't go to port 880, go through port 443 to access whatever you want to access. So people want to access this particular web server, they will access it through this particular port. So you send me for your server and say, if you are going to the internet, I'll give you a port you can go through the internet with. It's only that port that will be permitted so that people can take advantage of it and say, well, I know there's a port that is available. And you can also restrict it in a way that this particular port for a particular set of IPs, and that is the whole essence of having IP address and having it as static, is because of permission purposes. And say, if I don't allow your IP to go to the internet, you cannot go. So it's only the IP that is permitted to go to the internet that will go to the internet and access whatever you need to access. I believe that is clear to you.
Okay, Mr. Sean, before you go, when you were trying to set up the VM, I think you mentioned a link that you would download from the Windows. I didn't get that point, but I told you to share the link. I don't know if you can go through that place quickly then.
What link do you talk about?
Yeah, I think I'm trying to get it. Come again? Not the virtual box.
The OS image. The OS image.
Okay,
we'll drop.
I will drop it on the Discord channel for us.
Yeah. So we'll drop it on the Discord. We'll drop it on the Discord channel, right? So again, because of the size of the ISO image, the size is like almost 4 gig. So maybe what might happen is instead of everybody to download it, that's why you all have to work as a group. Maybe one person should download or 2 people can download, and then you can install and maybe like have a session where you will now demonstrate all that has been done. Or if there's a miniature version, you understand, that can be downloaded for you to be used. I think that would be okay. So I think that answers it, right? We'll drop the link on our Discord.
Hello, but we spin a window server. Can't we be maybe like maybe Linux or another stuff we can?
Yeah, okay. So for that, right, because we're actually working on Windows, right? It has to be a Windows server. For next week, the session is going to be strictly Linux. Then by then you can use your Linux image, be it CentOS, Red Hat, or Ubuntu, anyone that you want to use. But for this one, right, you're expected to spin up a Windows server. It could be a Windows Server 2016 or Windows Server 2019 or 2022, as the case may be. So if you want to do that, you can do that. So the tax for this week.
Please, are we allowed to spin these machines on the cloud? Let's say some of us have some subscriptions.
Exactly. So good. I know that we are all, looking forward to, okay, let's go to the cloud. So again, the classes are, they've been sequenced. Do you understand? There's another sprint for cloud. So don't be in a haste to go to the cloud, because once you get your job, once you get your DevOps job now, and by adventure they don't make use of cloud in that organization, what will now happen? Will you now tell the CEO that no, it's only cloud that I know how to spin up a server? So that's why we're actually teaching you the basics, because it's not all organizations, that make use of the cloud infrastructure. There are some that are still using on-premise. And then we are saying, as a DevOps practitioner, we need you to have use cases in all of these areas. So don't worry about cloud. You will do so many things in the cloud, where we talk about AWS and Azure. But for now, we are taking it.
Another thing. I don't think not everybody on this class are so vast in all this cloud and all those stuff. So the way it's being taken step by step is all right, so that everybody, people that don't even know anything about these things to understand. I know many of us are vast in this area, but let's just be taking it the way we are taking it by
Yeah,
little,
Lawrence is noted.
Yes.
It's part of the concern, myself and Dapo, the founders, we discussed about that. Do we bring in cloud? So we felt like, let's talk about cloud first before we can even say, you can speak from the cloud, so that we can put everybody on the same page and we can all flow at the same pace. Because I know some of us, our level of exposure differs, so we are mindful of that also. So we have it, the curriculum is well structured to take you through all you need to go through to become a practitioner.
It's okay. I think that answers it. So again, it's going to be gradual steps. Do you understand? So that we don't complicate things along the way, right? That's why we have how many weeks? We have like almost I think 17 weeks, 3 months, so that once we get to the last month, right, we have all the information needed, both cloud experience, on-premise experience. We have all that are needed, you know, for you to become a DevOps practitioner. So don't worry. You get all of these things that are saying that are two fundamentals. Once you start getting to the main, you know, to advanced concepts, do you understand? I believe you would appreciate what we are doing now.
Okay.
Yep. So
Sorry,
Ademola,
sir,
do you have a
I'd like
question?
to ask.
Please go ahead.
Yes, sir. Please. So for me, for these assignments, can I use a VM just for compliance sake, because I'm using my office laptop? So, and I don't want to install a virtual box on it. So can I use a VM?
Yes, of course you can use a VM. The most important thing is just, let me just, that's for the class. Can you hear me?
All right.
Can you hear me? Hello?
Yes, I can hear you, sir.
Yeah, so I'm saying you can use any hypervisor. Yes, so you can use any hypervisor tool that you have, right? The most important thing is, irrespective of the hypervisor you are using, right? Just make sure that you are able to spin up a Windows server, right? And then we'll now take it up from there on Wednesday, where we'll talk about more server roles. Do you get? And that's where you're going to appreciate what Shane has been talking about now for the past 2 hours. Do you get? So if you want to use what is it called? If you want to use VMware, if you want to use VirtualBox, whatever hypervisor you want to use, even if you have all the luxury, if you want to spin up hypervisor 1, right, on a physical hardware, you can go ahead. But the most important thing is, right, just come up with a workable server. So for the tasks, just like Sean said, you can work as a group, right? Set up a server on your box and install a web server. So the web server can be an IIS. There's an IIS, there is Apache as well. So you can install any of that, so that on Wednesday, we'll just take it up from there. Right. So someone is asking a question here. Yes, okay, but note there is static IP too. Okay, I don't know what person. Okay, since IP address is dynamic, that it changes. If DCP is applied, can someone set a rule using MAC address such that only a set of MAC address can access a particular resource? Okay, so this is all about access control, right? So again, once we get to networking, right, you can ask the questions on access control. So I think that is that. So we'll just call it a day from here. So as usual, the material for this teaching has been posted on our resource page. So you are all expected as a team to work on the tasks. So the task is create a virtual box manager or a VMware player on your box, set up a Windows Server 2016 or a 2019, right? And then install a web server. That is all. That is all the task. So we'll meet again on Wednesday nights. I posted it already. We'll meet again on Wednesday by 10 p.m. right? Purely for hands-on sessions on further server administration tasks. So I think that is that. Does anybody have any question whatsoever? So that's, yes, please go ahead.
Okay, hi. Yeah, thank you for that, and thank you, Oluwaseun. I think Oluwaseun has really done a very, very good work and fantastic one. And on Wednesday night, we can also proceed further. And I could see people asking about, DHCP, static IP, and some other things like that. And I also believe it's part of the plan to also show you how to add, how to add a server to to a domain, show you about some other server roles that we have or some other server features. And they could go deep into, group policy management, telling you, okay, this is how a group policy, this is what an OU means, this is what a security group means. And also little information about, our remote desktop services that we have on Windows. But to be sincere, we are actually trying to make it very, very easy and simple. Because yes, we understand that, many of you are very, very little, understanding, and some are advanced. And nonetheless, whether it's going to be on